Hello everyone, welcome to Electric Motors course. In this lecture, we will discuss about the losses in DC motors. So losses in DC motors and as well as the losses in DC generators are same. So when we can say losses in a DC machine. So let us discuss the various losses that occurs in the DC machine. So the various losses in a DC machine, whether it is a motor or generator, are classified into three groups. One is the copper loss. Second one is the iron loss, or it is also called as core loss. Third one is mechanical losses. So we will discuss one by one what is copper loss, iron loss and mechanical loss. So these are the three losses that occurs in either it may be a motor or generator. So copper loss is the loss which occurs in the windings of the DC motor. So in the DC motor, for example, we consider DC motor. In the DC motor, we will be having two windings. One is armature winding, one more is the field winding. For DC shunt motor, it is shunt field winding. For series motor, it is series field winding. For compound motor, it consists of both series and as well as shunt field winding. So wherever we have windings, there this copper loss will occur. Copper loss is also called as I square R loss. So it depends on mainly on the current flowing through the conductor or the winding, So this copper loss applied to the DC motor, so where we will be having the armature conductors and we will be having the field conductors, armature winding and as well as field winding. So there will be loss in the armature winding and as well as field winding. So let us consider a DC motor, either it may be a shunt motor or series motor. There will be always this armature copper loss, The formula for this to calculate the armature copper loss is, it is current flowing through the armature winding Ia square into resistance of the armature winding, that is Ia square into Ra, where Ia is the current flowing through the armature winding, Ra is the resistance of the armature winding. Similarly, we have field copper loss. For shunt motor, it is shunt field copper loss. The shunt field copper loss is given by the shunt field current ISH square into the resistance RSH. Similarly, if we consider the series motor, there will be series field winding. So series field copper loss will be given by the current flowing through the series field winding ISC, it is ISC square into the resistance is RSC. So these are the copper losses that occurs in a DC motor. So if you particularly consider the DC shunt motor, only these two losses will be there, that is armature copper loss and shunt field copper loss. In copper losses, there will be only these two copper loss, armature copper loss and shunt field copper loss. This is for shunt motor. For series motor, these two will be there, armature copper loss and series field copper loss. In case of the compound DC machines, both shunt and series field will be there. So in case of compound motors, all three, armature copper loss, shunt field copper loss and series field copper loss will be there in case of the compound DC motors. So this is about the copper losses that occurs in the DC motor. Now let us discuss the various iron losses that occurs in the DC motor or DC machine. The iron losses are due to the magnetic flux in the motor, or we call it as well as the magnetic losses. iron losses are also called as core losses, or these are also called as the magnetic losses, are also called as magnetic losses. So as the name suggests, it is magnetic loss. So this magnetic loss consists of again two losses. One is hysteresis loss, hysteresis loss, and one more is eddy current loss. So we have two types in iron or magnetic loss, hysteresis loss and eddy current loss. So we already know, we have studied in transformers these hysteresis loss and eddy current losses. So here also these hysteresis loss and eddy current loss are same. Hysteresis loss is occurred due to the continuous magnetization and demagnetization of the core part of the DC machine. The core part of the DC machine is nothing but it is the rotor, the rotor part in the rotor DC machine, that is where we will place the conductors. Right, we will be having rotor slots like this. So in these slots we will place the conductors. Apart from this, the remaining part whole is the core part. So in this core part, due to the continuous magnetization and demagnetization of the core, this hysteresis loss occurs, and the formula to calculate this hysteresis loss is given by the power loss due to hysteresis loss is equal to the hysteresis coefficient into the magnetic maximum flux density power 1.6 into F into V, that is volume of the core. So this is the formula that is used to calculate the hysteresis loss in a DC motor. It is in watts. So here this formula is called as the empirical formula. This is empirical formula, where this formula doesn't have any proofs. So this formula is obtained from the repeated experiments. This formula is obtained from repeated experiments. So those equations are called as empirical formulas, which does not have proofs. So from this equation we can find out the hysteresis loss, or we can calculate the hysteresis loss with the help of the curve called as BH curve. BH curve, it is the magnetic field intensity versus the magnetic field density. So if you plot the graph, your graph will be somewhat like this. It will be in terms of leaf. So area of this leaf, that is this is during magnetization, this is during demagnetization. Again the current will be negative, so again this will be decreasing. Again after this the current, the magnetic field increases in this direction. So the area of this leaf is also the hysteresis loss. This concept we already studied. Okay, so this is how we calculate the hysteresis. So it is due to the continuous magnetization and demagnetization of the core. Next we have the eddy current loss. The eddy current loss are due to the the magnetic flux. Eddy current loss are due to again the magnetic flux. Since the presence of the flux is alternating in nature, the alternating flux cuts the core. Since core is also made up of the conducting material, the EMF will be induced in the core part, and then there will be currents in the core part, and those currents will be in the form of circulating in nature, and those currents are called as the circulating currents are called as the eddy current loss, and there will be power loss due to this eddy current loss, and that power loss will be dissipated as heat in the DC motor core part. So that loss is called as the eddy current loss, and this eddy current loss, there is a formula to calculate the eddy current loss as well. It is given by K, that is constant, eddy constant, into magnetic maximum flux density square F square thickness of the core into volume of the core. So by using this formula we can calculate the eddy current. So these are eddy currents due to the electromagnetic induction principle. Eddy currents are induced in the core part due to induction principle. So we can minimize this eddy current loss and as well as the hysteresis loss is minimized by selecting the core material which has low hysteresis coefficient. The material should have this hysteresis coefficient we have. This hysteresis coefficient should be very less, then the power loss will be very less. While the eddy current is minimized by selecting the laminated construction of the core. The core can be constructed like laminated sheets. The core can be constructed with the laminated sheets like this. By this we can reduce the eddy current losses. So these are almost same. These losses, eddy current loss and as well as hysteresis loss. These two losses will be same for any DC machine. Once you design the DC machine, these losses will be treated as comes under constant losses. The last one we have last loss, that is the mechanical losses. So this mechanical losses again includes consist of the friction and windage losses. These losses includes friction and windage losses. So as name indicates, the mechanical losses, this loss occurs at the shaft of the DC motor, where the mechanical energy generated, that is the torque developed in the armature, is transferred to the load. Then this mechanical losses occurs due to the friction. Since the shaft is rotating, due to the friction there will be a power loss, and due to the wind resistance, since the wind will be present in the air, due to the wind resistance there will be power loss. So this is called as the windage loss. So totally put together, friction and windage loss are called as the mechanical losses. Now the mechanical losses and the magnetic losses. Magnetic loss and the mechanical losses put together, mechanical loss and magnetic loss put together is called as the stray loss in the DC machine or DC motor. Here we are talking about the DC motor. So the stray loss in the DC motor. So stray loss means it is the magnetic losses and the mechanical losses together. Magnetic loss and mechanical losses together is called as the stray losses. So if you consider for different machines, for example for shunt motor, for shunt motor we know that the shunt field current remains constant, ISH remains constant. Since the flux is constant, the ISH also due to the ISH constant, flux remains constant. So we know that field current in a shunt motor is constant. The field copper loss, that is ISH square into RSH square, this also constant in case of the DC shunt motor. So magnetic losses are constant, and for this mechanical losses are also constant in a DC machine. Mechanical losses, magnetic losses, mechanical losses, and this shunt field copper loss put together are called as the constant losses in DC machine. Constant losses in DC machine involves the magnetic losses plus the mechanical losses plus the shunt field copper loss. So these all three, magnetic loss, mechanical loss and shunt field copper losses, are constant for DC shunt motor. So the variable losses in DC shunt motor are, since the armature current depends on the load, the armature copper loss, I square RA, is the variable loss in the DC shunt motor. It is the only variable loss in the DC variable loss. So total losses in a DC shunt motor will be, it is variable loss plus constant loss, loss. That is, variable loss is the armature copper loss. Constant loss includes the magnetic losses, mechanical losses, and as well shunt field copper loss. For series motor, these losses, since the field winding is connected in series with the armature, the current through the field winding is not constant as in case of the DC shunt motor. Here it depends on the load. So here the total losses will be equal to, and in this series motor the constant losses are only the magnetic losses and the mechanical losses. Only magnetic and mechanical losses are the constant losses in case of the series motor. The variable losses include the armature copper loss and the field copper loss, ISC square into RSC. So since ISC and IA both are same here, we can take this common. IA square into RA plus RAC is the variable loss in case of the series motor. So then the total losses again here is total losses in this series motor. It is again variable loss plus constant losses. Variable losses and constant losses are the total losses in case of the DC series motor. So this is about the losses in the DC machine or DC motor. These losses will be again same for DC generator also. Thank you.